Hello, this is Garrett, and this is my Data Science Practicum 2 final project presentation video. This video will mainly be a walkthrough of the Markdown README for the repository, which is partially showing on screen, but I'll also have a chance to take a deeper look at the underlying dataset and the notebook that I use as well to create the machine learning models for this project. As you can probably tell from the repository name and the top of the Markdown description, this project is dealing with prediction of patient readmission in hospitals. In this case, an early readmission would be defined as an admission of a patient within 30 days of being discharged from their previous admission. Being able to predict whether or not a patient will be readmitted within 30 days is useful for both the patient and the hospital. To start off, I'll be looking at the data and giving an overview of the data in its raw format. It comes in 3 different files, so I'll be giving an overview of those. And I'll be giving an overview of my findings and exploratory data analysis in the notebook and a few visualizations as well. So let's start off with the data. In the Markdown, I give a screenshot showing the first 5 rows of the data. It's kind of hard to see, but I just wanted to show a few rows just so we can get an idea of what different features exist as columns in this dataset. Overall, there are over 100,000 rows in this file, but I'm just showing the first 5 just so we can get an idea of the different columns. So we can see an encounter ID is basically an admission ID. So anytime a patient comes to a hospital and is admitted, that entire process is given an encounter ID. Patients are given IDs as well, and there's some demographic information included. And scrolling on, we can see different counts. So number of procedures done, number of medications, and number of diagnoses are shown. Diagnoses themselves are shown as codes. These are categorical. They correspond to different coding systems. And then there are a lot of columns here for different medications, and a medication can be non-existent. So if it's no, then this encounter, this admission, this drug was not used at all in that case. It can be also steady, up, or down, and that's designating the change, if any, in dosage levels during the stay. And then moving on, you can see towards the end markers for whether or not the patient is diabetic, and this is the target column which we're trying to predict. It can be no, greater than 30, or under 30, which isn't shown here, but it's another option. So greater than 30 means that the patient was readmitted after 30 days from this discharge, and under 30 obviously means that's an early readmission. They were readmitted within 30 days of this encounter, this row. And no means there's no readmission on file after this event. And I don't know why, but towards the end there is birth date and admission date. But I figured these could probably go earlier in the file, but no matter. You can look at the README to see the main takeaways from the data analysis section, but here we'll be going over the notebook. So here I'm just reading the data in and looking at the different columns and their types. And then this is a value count, so we can see the balance of classes, the distribution of classes in this data set. So we can see that only about 11% of admissions are actually targeted as early readmission. And so that will be an issue later for the machine learning, but going further, so this is the section that I mentioned with the reference tables where the ID mappings map to the codes for specific columns map to different descriptions. This section here actually replaces the values in the data frame with the description, and that's done right here. And we can see in, like, for these examples, I mapped codes 18 and 26. These basically map to null values, so I just replace them in the data itself. So finally getting into part 2, the machine learning. This is where things get interesting in my mind. A little bit of pre-processing work is done, is required for this project. As I said earlier, some of the data needs to be cleaned up. IDs need to be mapped to descriptions, and null values need to be put in. And there's quite a bit of missing data, so having to fill that. Feature engineering is another very interesting aspect of this project. One thing I wanted to look at was the time since last admission. Since a patient can appear multiple times in the dataset, I wanted to find out at each admission how many times prior to this admission have they been admitted. So as of some date, how many times does this patient number appear in this data frame? So that's what this is calculating for each person, and it's also doing the count of previous admissions in this function here. So those are two features that I wanted to engineer that I thought would be relevant. This method here actually takes the entire data frame and basically pre-processes it and prepares it for any type of modeling. So it does types, it castings is categorical after categorical, it scales data, and when I comment out stuff like this, it means that everything but no is basically just one level. It's a categorical level that only is basically one thing almost all the time. So I just ignore them. So these are where I get into new features. Some things I wanted to calculate to add were time of day of the admission and maybe the discharge, and the day of the week that they were admitted. And so those are some of the things. And it also calculates these two features that I showed in the methods above for number and time since previous admissions. With a lot of the nitty-gritty details out of the way, let's go back to the README and just give an overview of the model results. So, starting with LightGBM. LightGBM is a favorite model of mine. It's very fast, it's very easy to work with, it's very efficient with memory, it's just very easy to train, and generally has pretty good results. As you can see in this case, the results are not that great, although it has a little bit better accuracy than no accuracy. Precision is basically perfect, but the recall is absolutely terrible. In this case, the model is just failing to pick up on, it's failing to catch many of the early readmission cases, so maybe not that useful of a model. So let's look at TensorFlow. So after making the categorical data, encoding that with one-hot encoding using pandas get dummies, we can actually use the same data with different model types. So TensorFlow, it actually turned out a bit better, maybe, I don't know. Lower precision, higher recall than LightGBM, but still not that great. And as we can see here, TensorFlow resampled. This data is actually imbalanced. If you recall, only about 11% of the data is actually early readmission, so I wanted to undersample the data to train the model on data that's evenly split between positive and negative cases. And this turned out to be a big help, actually. While the overall accuracy is lower, I think the recall improvement is probably justified. Precision is pretty low, it's the lowest so far, but it's actually somewhat usable, and now you're actually catching a significant portion of all the cases that are resulting in an early readmission of a patient. finally, we're looking at logistic regression. I think this is kind of a good base model to compare different machine learning models to. It's still very popular across many different analytics units. And so I just thought I'd throw it in there as a last second thing to compare these different models to. We can see from the plain logistic regression that it kind of fell into the same trap as light GBM, in which case it had high accuracy, but okay, pretty good precision, but also still terrible recall. And even though like the ROC AUC, that score is still pretty good compared to the other models we've looked at, but still looking at recall, it's just not catching a significant number of cases which we want to look at. So looking at the same technique as with TensorFlow to undersample the data and train the model on that and then evaluate on the original distribution, we see that the accuracy is the lowest we've seen so far out of all the models. Precision is also probably the lowest, but the recall is actually higher, so it's catching more of the early readmission cases, which may be good, depending on what the, I guess, end goal of the model is. And that's kind of where we draw into the final conclusion and thoughts. So before we get into a sort of analysis, let's just look at an overview of the different metrics and evaluations of the different models. So we can see different graphs for accuracy in the models, precision, light GBM way up there, perfect. Others, they're getting there. Recall, kind of same story I already talked about, and AUC pretty similar across the board. So it's kind of hard to choose a model here, and this is where we get into the final thoughts. So which model is best? It depends. Like I said, it can never really come down to just looking at a single metric, even ROC. It just depends on the context of the problem. So things I would like to consider in this case when choosing a model, what action, if any, is taken when a patient is deemed as high risk. So if model predicts 1, that the patient is at high risk of being readmitted within 30 days, what are we going to do about it? What are the costs associated with that? And if it turns out to be a false positive, then is that much of a wasted effort? I don't know. What are the consequences of failing to predict early readmission? So this is what's the consequence of a low recall? If we're not finding a lot of the early readmissions, what are the implications of that? So I don't know the answer to any of these questions, but it's something that someone who's more familiar with hospitals and predicting this work, actual stakeholders in this business problem, what their concerns are, that's something that would need to be defined and worked on to actually come to a conclusion on what model, if any, is appropriate for this use case. So that concludes my presentation, and this is all on the GitHub, so you can take a look at that whenever you want. Thanks for watching the video, and have a good day.